Okay, so today we'll be looking at what I would consider to be one of the most fundamental, important skills that you need to master in order for you to succeed not only in this course, but future chemistry courses, including Chem 1, Chem 2, Organic 1, Organic 2, and all that. And that skill has to do with balancing a chemical equation. Very important. Firstly, let me ask, can you all hear me? I'm getting a sneaking suspicion that I'm talking to myself, but please. Oh, okay. Thank you, Miss De La Vega. All right. Um, okay, so let me get to where I want to get to. Um, so let me just say a couple of words first before we get into the actual assignment, which is, of course, assignment number 6. And basically, balancing an equation is, well, firstly, let me just say this. So, and I think I've made mention of this earlier. An equation is basically a shorthand way of representing what happens in a chemical reaction, right? So, um, in a typical equation, why is this thing not behaving itself? Let me see here. Let me see here. I'm sorry, folks. I don't know why this thing is so slow today. Okay, so in a typical equation, you have the formula for the reactants on the uh, you have the formula for the reactants on the left side, right? Then you have an arrow, and then you have the products on the right side. And you may have some symbols here which indicate the type of condition. So for example, you may see, for example, delta, which represents heat, or you might even be given a specific temperature like 250 degrees. You may be given a pressure if gases are involved. So you may be given something like you may be given something like 2.5 atmospheres for pressure and so on. All right. Um, However, you may be given some more details about the reactants and products, right? So just to give you a simple example, you may be given something like this: C plus O2 to give CO2, all right? Now, you might be given, again, some other, state symbols, we call it, which basically indicate the states of the substances involved. But you can also be given some important information which represents the quantitative relationships between the substances in this particular reaction. So in this particular reaction, you'd have a number like here, 2 here and a 2 here. And basically, they give you the proportions of the different substances involved in the reaction, right? And that's very important, especially for later on, where we have to do calculations based on these numbers. In chapter 7, I think it is. No, not chapter 7, chapter 8, where, for example, you might be given a question where, for example, you might be given a certain amount of reactant, and you're asked to determine the amount of products you expect to get, right? So these numbers will become important when it comes to doing those kind of questions. So these numbers, while we have them here, I'm going to say what they are. In chemistry, we call them the coefficients, right? And these coefficients are not to be confused with these numbers here. These are basically the subscripts, right, for the different elements in the different compounds. So these are the subscripts, right? So it's very important that you're able to make a distinction between the two, right? The coefficients would be the numbers that are placed in front of the formulas for the different substances in the equation, while the subscripts would be the numbers which represents the number of atoms of each element present in the molecule or in a formula unit of an ionic compound, right? So you should not confuse those two numbers, all right? Now, the coefficients are important because, as I mentioned before, it gives you the relative proportions of the number of atoms being present. Now, the key thing that you need to remember is that the balancing of equations is based on the conservation of mass law. And just to remind you, the conservation of mass law says that in a chemical reaction, the total mass of the products will be equal to the total mass of the reactants, right? Or another way of stating it, matter is not created nor destroyed in a chemical reaction. And the reason why that is so, the reason why we know that law to be, or the reason why we observe that law is because of one of the postulates of the Dalton's theory, which says that atoms are not created nor destroyed in a chemical reaction, right? So basically, whatever the number of atoms of a particular element that is present in the reactant or reactants will be the same in the products. And we indicate that by using the coefficients here. Now, let me erase something here so as to explain further what I'm talking about. So I'm going to erase the coefficients here. And let me rewrite carbon here and carbon dioxide here, right? Now, previously, in fact, let me just, oops. Let me just erase all this here to avoid confusion. Okay, so previously you could be given this equation here, right? And if you look at this equation here, you'll see that, okay, based on what we have here so far, we have one carbon here and one carbon here, right? So basically, there are no carbon atoms created nor destroyed in this reaction. In the case of, oh shoot, I just remembered something. This is a poor example. Okay. I made a mistake, right? I put a 2 here. There should not be a 2 here or 2 here. So let me use a different example. I'm sorry about that. Let me use the reaction between hydrogen and oxygen to form water, right? That's a better example. So H2 plus O2 to give H2O, all right? So let's say you're given this, right? So let's look at the hydrogens on both sides. You have 2 hydrogens here, you have 2 hydrogens here, so that's, there are no atoms created nor destroyed, as far as the hydrogens are concerned. But as far as the oxygens are concerned, you have 2 here and you have 1 here, all right? So in this case here, their oxygens are out of balance, right? Because here we have 2 oxygens on the left side, here we have 1 on the right side. So basically, as it is right now, this is not obeying the law of conservation of mass, right? Because somehow you have 1 more oxygen here compared to the oxygen here, right? So what we need to do in order to ensure that this equation falls in line with that law, we have to make sure that the number of oxygens on both sides are the same. So how do we do that? Well, let me tell you what you cannot do first, and then we can get into how we correctly balance this. What you cannot do, for example, is simply add an oxygen on this side, right? You cannot do that, okay? So even though that may achieve the balance in terms of the number of oxygens on both sides, you simply cannot add an oxygen to the right side to balance the oxygens, right? So that's a no-no when it comes to balancing equation, right? Another thing you cannot do is change the subscript, right? So in this case here, you have a subscript of 2. You might be tempted to put a 2 here. Cannot do that, right? Because by doing that here, you're basically creating on paper a different compound from the compound that was there, right? So before we had H2O, now we have H2O2. That cannot work, all right? So those are 2 things that you cannot do when you're balancing an equation. What you need to do is make adjustments to the coefficients, right? So as I said before, the coefficients are the substances, or I should say the numbers that are placed in front of the formulas for the different substances. So in this case, the way I would balance the oxygens, is that I would put a coefficient of 2 here in front of the H2O, right? So therefore, these 2 oxygens here will balance with the 2 oxygens here, all right? So that's how you balance oxygens. However, this will not be the end of the story, because now that I've placed a 2 here in front of H2O, that 2 would also affect the 2 hydrogens, right? So therefore, now I'm going to end up with 4 hydrogens, and here I have 2. So what do I need to do? I need to put a 2 here, and therefore now the oxygens are, I'm sorry, the hydrogens are balanced, and also the oxygens, right? And therefore, this equation would be a balanced equation. Excuse me. All right? So that's basically how you go about balancing equations. What you have to do is go back and forth between the reactants and products and make adjustments to the coefficients. You don't make adjustments to the subscripts. You don't simply add an atom of a particular element to either side. You make adjustments to the coefficient. And it's a bit of a trial and error kind of situation, because sometimes you may make an adjustment and place a number in front of a formula, and later on you have to basically change it. In fact, let me see if I can come up with another example. Hopefully I won't screw this up. So let me erase this top part here. In fact, any questions about this? Any questions about this example I did? Any questions? Yes, in fact, I'm going to publish it shortly. Somebody's asking a question about will the chapter 6 assignment be available? I'm going to make it available shortly, but I need to just explain a couple of things to you guys. Okay, so let me clear this. And let me come up with another example. So let's see here. Oh, no, that won't work. Suppose I gave you CH4 plus O2 to give CO2 plus H2O, all right? So that's the equation, and you're asked to balance it, right? So first thing I would do is look at the carbons on both sides, and I see that I have 1 carbon atom here, 1 carbon atom here. So as far as we're concerned, for now, the carbons are balanced, right? Then we move on to the hydrogens, and we notice here that we have 4 hydrogen atoms expressed here, and here we have only 2, all right? So what I would do is put a 2 here, all right? So the hydrogens are now balanced. Then I would move on to the oxygens, and what do I notice? I notice that we have 2 oxygens here, and we have 2 plus 2, because remember now, this 2 affects everything within the formula here. So we have a total of 4 oxygens on this side. We have 2 oxygens on the left side. So what I would do is put a 2 here, and now everything should be balanced. And what I would normally suggest you guys do is that you go through and check to make sure that everything is balanced. So we have 1 carbon here, 1 carbon here. We have 4 hydrogens here. We have 2 times 2, 4 hydrogens. And we have 4 oxygens here. And we have 2 plus 2, 4 oxygens. So now the equation is balanced. All right? And that's it for this question. So, or for this example. Any questions about this one? Any questions? Any questions? Any questions? Oh, I see a question. Oh, okay. You're welcome, Miss Taylor. All right. Let's do this example. Now, this one will be a bit more challenging, but I'm going to go through it and explain to you how I would go about solving this. Let's see here. H2O plus hold on. O2. Okay. So let's see how we go about this. So we're going to go through the steps just like before. Starting with the hydrogens. We have 1 hydrogen here. We have 2 hydrogens here. All right. So what I would do is put a 2 here. All right. Then I would focus on the nitrogen. Now, because I put a 2 here, that 2 would affect everything within this formula. So that means that there are 2 nitrogens shown here. There's only 1 here. So I would put a 2 here. So now we get to the oxygens. So this 2 here would multiply the 3 oxygens here. So I'll end up with 6 oxygens, right? On the left side. On the right side, I have 2 times 2, 4, 4 plus 1, 5, 5 plus 2, 7. So we have a situation here where we have 6 oxygens on the left and we have 7 oxygens on the right. So the question now becomes, how do I balance oxygens? And this is going to look weird, but this works actually. So what I would do is put a coefficient here of a half, right? Now, normally, the coefficient should be an integer, and we're actually going to change this into an integer, but in this particular case, I'm going to temporarily put a half here so as to achieve the balance of the oxygen, because when you put a half here, half times 2 gives you 1, plus 1, that's 2, plus 4, that's 6, and that balances with the 6 oxygens on the left, right? So basically, at this stage, all the atoms are balanced, the hydrogens, the nitrogens, and the oxygens. But as I said before, we need to make sure that all the coefficients are integers. So how do we achieve that? What I would do is take this equation and multiply it right through by 2. Because when you multiply a half by 2, that would give you 1, which is an integer. But you have to multiply everything by 2. You can't just multiply this one by 2, all right? So that means that this becomes 4HNO3 to give 4NO2 plus 2H2O plus O2. And this should be the final answer. Again, we can check to make sure that everything is balanced. So we have 4 hydrogens, 4 hydrogens, 4 nitrogens, 4 nitrogens, 4 times 3, 12 oxygens, 4 times 2, 8, plus 2, 10, plus 2, 12. So therefore, we now know that this equation is balanced. All right? Okay, any questions about this one? Any questions? Any questions? Okay, so let me clear this. And let me put another example on the board or on the screen. Okay, and I want to hear what you guys would have to say about this one. So how would you go about balancing this one? Well, any ideas? Okay, let's see. Somebody's responding in the chat. Add a coefficient of 2 to the carbon dioxide? No, why would you want to do that? And this is Pierre who said this.
Would you put a 6 in front of the CO2?
That's what I would do
And then,
because you have 6 carbons here. So yes, I'd put a 6 here.
and then would you put a 3 in front of the H2O?
Exactly, because you have 6 hydrogens here. I will put a 3 here to make that a total of 6 hydrogens on the right side. Okay, what next?
You put a 4 in front of this O2?
I'm sorry, repeat that.
Actually, never mind. I think I got it wrong. Sorry.
Okay, how many oxygens do we have on the left side? Okay, somebody said something in the chat. Okay, somebody says 15 oxygens. No, I said the left side, not the right side. But since you said that, and this is Denizar. I think that's the way I pronounce Denizar Tanon. Since you mentioned that, I'll go ahead and say, yes, I agree with you. You have 6 times 2, 12, plus 3, so that's 15 oxygens on the left side. How many total do we have on the right side? I mean, on the left, I'm sorry, I'm confusing the sides. We have 15 oxygens on the right side. How many do we have on the left side? 8 so far. On the left side, you sure about that? 2. Somebody said 2. Cassidy said 2. Okay, so we have 2 oxygens on the left side, 15 on the right side. So my question to you is, what do I multiply this by in order to get 15 on the right side? Okay, somebody said, let's see here. Okay, somebody actually jumped the gun and put the right answer. Okay, your answer is correct. Who said this? Bonamy. Yes, your answer is correct, but I like to go through the steps so that your fellow students can benefit from knowing how to get the answers. So what I would do in this case is that I would multiply this by 15 over 2, right? 15 over 2 times 2 gives you 15, which balances with the 15 on this side. So I'd put 15 over 2, and somebody just said something in the chat. Let me see here. Oh, don't apologize, don't apologize. Okay. So, what was I saying? Okay, so that's the reason why I put 15 over 2 here, so as to balance with the oxygens on the right side. And then, just like in the previous example, what I would do is try to get rid of this fraction and convert it into an integer, which means that I'm going to multiply everything by 2, which is 2C6H6 plus 15O2 to give 12CO2 plus 6H2O. And that would be, or should be, the final answer. And again, I will check to make sure everything is balanced. 12 carbons, 12 carbons, 12 hydrogens, 6 times 2, 12 hydrogens, 15 times 2, 30 oxygens. Here we have 24 plus 6, 30. So that equation is balanced. All right? Okay, any questions about this? Any questions? Any questions? Okay, so what I'm going to do now is, okay, what happened here? Okay, so let me get out of this here. And okay, so this is chapter 6. Let me see. I don't think I published it yet. So let me do that now. So assignment number 6 is what we'll be focusing on today. Okay, so for you guys out there in Zoom, which is everybody, you should now be able to access assignment number 6. I've just published it, all right? Okay, so this is assignment number 6. It's in different sections. So the first question in the first section is asking for you they give you a series of formulas, right? And it says you're to draw a circle around each subscript and a square around each coefficient. Okay, so in this case, remember now what I said earlier. The subscripts would be the number, the smaller number that is placed to the right of the formula for a particular element in a compound or in a molecule, which basically indicate the number of atoms present per molecule. And the coefficient would be the number that is placed in front of or to the left of the formula, which indicates the number of atoms or molecules or whatever, all right? So that means that in this case here, in the case of H2O, we'd have to put a circle around the 2 here because that's a subscript. In the case of the 5Cl2 here, I'll place a circle here and place a square there. In the case of the magnesium, that would have a square around it for the two. And in the case of the hydrogen peroxide, I'll put a square here and put two circles around, one around each of the subscripts for hydrogen and oxygen. And that's it. That's basically what this question is asking for. All right? Okay, any questions about that? Any questions? Any questions? Okay, the next question, let me just slide this down here, scroll this down here, is asking for you to balance the following chemical equations. Let me clear this as well. Okay, so how would you balance the first one? Number one. Okay, somebody just said something in the chat. Okay, so all right, I'm looking at your answer. Who is this now? Javon, not quite complete. You're right about putting a 2 here. Um, and you're not quite right about putting a 2 here. Let me see here. You're right about everything else, actually. Yeah, so you can leave the, by the way, I should have mentioned, um, there's only one that should be here and one that should be here. That's it. That's a final answer, right? You can leave these blank because basically it's understood in chemistry that if you don't have a number here, that number is one, all right? So the actual answer is what you see here on the screen. Mr. Oliver mistakenly put a 2 here, but that's not correct, all right? Because if you put a 2 here, the carbons will not be balanced, all right? Okay, any questions about this? Let me erase this here. Any questions? Any questions? Okay, what about the next one? Let me clear this. Scroll down. Okay, so what say you guys about number two? How would you balance number two? Okay, let's see what this person says. Okay, so this person, I'd like to give credit. Okay, so Ian Denizar Tanon is a person who mentioned something in the chat, and he is correct in that you have a 2 here and a 2 here, and that's it. All right, very good. Okay, any questions about that one? Any questions? Any questions? All right, the next one. Let me hear what you guys have to say about number 3. Okay, somebody said something in the chat. Let's see what he or she has to say. Okay, so this is Javon, and he is saying that, okay, yep, that's correct. So 2, 2, and 3 would be the answer for number three. Very good. Any questions about that one? Any questions? All right. Let me clear this. Scroll down. Okay, number four. Who'd like to tell me what they got for that one? Okay, let me see. Somebody said something in the chat. Okay, that is indeed correct. And this is, who is this? Bonamy. So let me put what he said or she. I don't know. I don't know if it's a he or she. I'm sorry. I'm sorry if I misrepresented your gender. Okay, but this is what he or she said, and that's correct. All right. Okay, any questions about this? Any questions? Any questions? Any questions? All right, let me clear this. Okay, number five. Let me hear what you guys have to say about number five.
There'd be a 3 in front of the Z and S.
Okay, so you're saying a three here,
Yeah. And then a 2 in front of the aluminum and
phosphorus, aluminum phosphide, that's the name of it. Anyway, and what else?
nothing else.
Nothing else? Okay, yeah, I would agree with that too. Yeah. Okay, very good. Very good. So that's the answer for that one. Any questions? Any questions about this one? Okay, number six. Let me hear your ideas about that one. Okay, let's see what this person says in the chat. Okay, I would agree with that. Yes. Who is this? Kingsley. I would agree with that. Kingsley is saying that there should be a 2 here, a 1 here, and a 3 here. All right, very good. All right, so that's as far as that part of the question or that section is concerned. Um, okay, let me clear this. Scroll down. Okay, so in this part, you're given two equations, and you're asked to circle the equation that is balanced. All right. So let me hear what you guys have to say about this one. You're going to compare the two equations and say which one is balanced. Okay, so somebody said something in the chat. Two persons actually, and both persons are correct. A is the one that's balanced. Okay, what about number 8? Of those two equations, which one is balanced? Let me clear this here. Okay, so yeah, which one of these two is balanced? Okay, let's see here. Two persons again responding, and both persons are correct. It is again A. Okay, moving along. Let me clear this. Scroll down. Hold on, let me clear this first. Number 9. Which of the two is balanced in the case of number 9? Okay, somebody did. Okay, 3 persons responded this time, and all persons are correct. The answer is B for number 9. And then for number 10, which one of the two equations are balanced? For number 10, Okay, let's see. Two persons has responded. Actually, three persons have responded, and all three persons are correct. The answer is A. Okay, very good. All right. And I think that's it for these types of questions. Okay, so let's move on now to section B. And in the case of section B, you're given, some sentences with some gaps where you need to fill in the right terms, all right, based on what we have just discussed. So the question says, fill in the spaces with the appropriate words in the following statement and balance the equations below. So there are some equations below that we need to balance, all right? So let's start off here. It says atoms are not blank or blank during a chemical reaction. So what two terms do you think should be filling these spaces? Okay, let's see. Somebody said two persons. Okay. Created or destroyed. Exactly. So created or destroyed during a chemical reaction. Okay. So far, so good. Then the next part says, or the next sentence says, chemists know that there must be the blank number of atoms in each of the blank. So let's hear what you have to say about that. Let's see here. Okay. Uh, okay, somebody said, I think this is Pierre, balanced. I'm not sure where that would fit into those spaces here. Look at the sentence carefully. It says chemists know that there must be the blank number of atoms on each blank of the blank. All right. Let's see what this person is saying. All right. So two persons says, um, okay, hold on. Things are coming kind of fast at me right now. Hold on 1 minute. Okay. So two persons says same. And I presume they're talking about this blank right here, this blank space. And I would agree. You could say same or equal number of atoms on each what? Okay, so let's see. Okay, so somebody's saying side, which would go here, of the, and then somebody said, hold on. Okay, somebody said the coefficients. I'm not sure coefficients would go there. Equation. Okay, so Bao, I don't know if I'm pronouncing your name right, said equation, which should go here. I would agree with that. Okay, and then now to balance the chemical equation, you must add. Okay, so let's see what you guys have said about that. Um, Let me see. Okay, somebody, um, De La Vega and Denizar Tanon, both said the same thing, which should go here, coefficients. Coefficients. Okay. And then continuing in front of the chemical formulas of the equation. You cannot blank or blank subscripts. Okay, let's hear what you guys have to say about that. Okay, so some people use different terminologies, which, from what I can see, they can all be used. Um, so somebody said remove or change. So you could say remove or change subscripts, or somebody could say remove or add subscripts. Any similar terminology can be used, which would be just as correct. All right. Okay, very good. All right. So basically, we have finished that section or that part of section B. So now we're going to get into the actual balancing of equations. So let me clear this and let's start off with a couple of these. Balance the following equations. All right. So let's start off with the first one. Let me hear your ideas about balancing that one. How would you go about balancing that equation? Okay, let's see. Somebody says something in the chat. Okay. Well, actually, to be perfectly um, factual, you cannot use zero, right? It would have to be one. Yeah, exactly. No, somebody said 2, 3, 3, 1. Well, the two would not be right. The actual answer is this: three here, three here, one here, one here. You don't have to put the one. And this is an answer to Miss Taylor. Um, if you put a two here, that multiplies this 3 by 6, which will not balance with the 3 sodium hydroxide here. So there should not be a 2. So this would be the answer. Let me see what this person is saying. Oh, yes. Okay. Yes, Miss Taylor. Yes. Okay. Okay, and that's it. That's it for that question. All right. So that's number one. What about number two? What about number two? Okay, let me see. Okay, nobody has said anything yet. Okay, two persons has responded so far. Let's see. Okay. Pierre and Oliver responded, and they're both correct. Pierre is saying just put a two here, and that is correct because once you put a two there, everything else is balanced, right? Um, okay, so that's it for number two. All right. What about number three? Okay, so let's see here. Two persons responded. 132. Yep, I would agree that. One here, three here, and two here. All right. Okay. Um, what about number four? Okay, somebody has responded for number four, and that person says 22212. Sure about that? Somebody said 22212. That's Javon Oliver. I'm not in agreement with that. Okay, so okay. Okay, man, you guys, the messages are coming quick. Okay, so Dennis, I keep mispronouncing this guy's name. Denizar Tanon and Bao, you're both correct. It should be 2, 1, 1, 2. All right, and that's it. Okay. Okay, what about number five? Okay, let's see here. For number five, again, correct. Um, Oliver and somebody else and Bonamy um, replied correctly. 2, 1, 1, 2. Okay, number six. Okay, let's see here. Somebody responded. Okay, and this is Dennis Tanon, and he's saying 1, 2, 1, 2, which is indeed correct. So 1, 2, 1, 2. All right. So what I'm going to do is I'm going to leave the rest of you, the rest of this. Let me just check something here. All right. So Um, I'm going to leave the rest of section B for you to do, right? As you can see, quite a few problems. Now, a total of 37 equations for you to balance, all right? And of course, if you have any issues while doing them, please feel free to contact me, and I'm more than willing to help you. Let me just see what section C is. All right, let me help you out with a few questions from section C. Now, in section C, they gave you some reactions um, where they describe what happens in words, and basically, based on the information provided, you're to come up with a balanced equation for each of these. All right. So in the case of the first one, it says potassium reacts with water, yielding potassium hydroxide and hydrogen, right? So whenever you're doing these kind of questions, you have to read it carefully to decide, firstly, what would be the reactants and what would be the products, right? Then you'd have to figure out the formulas for these substances. And then you do the balancing, all right? So let me show you how to do that for the first question in this section. So it says potassium reacts with water, yielding potassium hydroxide and hydrogen, right? So the first thing I would do is identify what the reactants are. And the reactants would be, in this case, the potassium and the water, right? These are the reactants, all right? And then I would determine what the products are, which would be the potassium hydroxide and the hydrogen, right? So these are the products. All right. So, of course, conventionally, the reactants would be placed on the left side of the equation and the products would be on the right side of the equation, right? So now we have to write down the formulas for the substances for the unbalanced equation. So on the right side, I'm sorry, on the left side, I'm going to put the formula for potassium, which is K, and I'm going to put the formula for water, which is H2O. All right. And then on the right side, I'm going to put the formula for potassium hydroxide. So this is the reason why we did those problems where we learned how to write down the formula for different substances, right? So basically, you're going to need the tables with the list of ions, and you look for the formula for potassium and the formula for hydroxide, and therefore you put them together to form KOH, and that would go right here, right? Then the formula for hydrogen. Now, I don't remember if I told you this, but I'm quite sure I mentioned this in the videos. Hydrogen is one of those elements that exist in nature as a diatomic molecule, right? So therefore it exists as H2 in nature, right? So you don't just simply put H there for the formula for hydrogen, you put H2 because hydrogen exists as a diatomic molecule by itself in nature. In fact, while I'm at it, let me just give you a list of diatomic molecules that exist in nature. You have hydrogen, you have oxygen, you have nitrogen, you have fluorine, chlorine, bromine, and iodine, right? You need to remember these as existing as diatomic molecules. And there are some other molecules or some other elements that exist as polyatomic molecules. You have sulfur and you have phosphorus, right? These exist as you can see here. For every molecule of sulfur, there are 8 atoms. For every molecule of phosphorus, there are 4 atoms, right? So you need to memorize these elements. These up here exist as diatomics, and these down here exist as polyatomics. Very important, all right? Okay, so going back to balancing the equation. So now we have to balance this. So first I'm going to look at the potassium. You have one potassium here. You have one potassium here, so that's fine so far. Here we have 2 hydrogens here, right? And here we have 1 plus 2, so that's 3, right? So to balance the hydrogens, what I can do is put half of H2 here so that you end up with 1 plus 1, 2, which balances with the oxygens. I'm sorry, with the hydrogen on this side. And then finally, we have 1 oxygen here, 1 oxygen here, so the oxygens are balanced. But of course, we cannot leave this with a fraction here as a coefficient. So what we have to do is multiply everything by 2. So the final equation is going to be 2K plus 2H2O to give 2KOH plus H2. And that would be the final answer with respect to balancing that equation. All right? Okay, any questions about this one? Any questions? Any questions? Any questions? Okay, let me clear this to avoid confusion and move on to question number two. So question number two, same idea. You have to identify what the reactants and products are. So in this case, it says chlorine reacts with potassium bromide, yielding potassium chloride and bromine. So what I would do is identify the reactants, which would be these here, right? So, and the products, so these would be the reactants, the chlorine and the potassium bromide, and the potassium chloride and the bromine would be the products. All right. And then I would write down the unbalanced equation with the reactants on the left and the products on the right. So in this case here, now chlorine is one of those diatomic molecules I mentioned before. So I'm going to put Cl2 plus potassium bromide. The formula of that is KBr. And then on the right side, I'm going to put the formula for potassium chloride, which is not P, KCl plus the formula for bromine, which is Br2. And then we have to balance it. So the way I'd balance it is, well, firstly, identify that there are two chlorine atoms here. There's only one represented here. So I'd put a 2 here. Here we have one potassium. We have two potassiums here. So I'll put a 2 here. And here we have two bromines. Here we have two bromines. So now the equation is balanced. All right? And that's it. Okay, any questions about this one? Any questions? Any questions? Okay, if there are no questions, let's look at number three. In the case of number three, in fact, let me hear what you have to say about number three. All right. In number three, it says zinc plus hydrogen chloride yields zinc chloride and hydrogen. All right. So I want you to tell me first what would be the formulas for, well, let me ask you this first. What would be the reactants and what would be the products based on the information provided here? What would be the reactants and what would be the products? Okay, somebody is responding. Let's see. Hold on, wait a minute. Okay, so Taylor says zinc and hydrogen chloride would be the reactants. I would agree with that. So these would be the reactants. And the products would be, the potassium chloride and bromine. I'd agree with that too. So, no, I'm sorry. I think you look at the wrong question. What would be the products in number three? Okay, so zinc chloride and hydrogen. Yes. Okay, so these would be the products. All right. So next thing we have to do now is figure out what the formula for the reactants will be, which will be on the left side of the equation. What will be the formula? Okay, so let's hear or let's see what this person is saying. Okay, you're right. It would be Zn, which is the formula for zinc, plus HCl. So what would be the formula on the product side? Okay, somebody responded. Let's see what he or she's saying. Okay, so you're partially right. Who's this responding? Mr. Pierre. Well, let me see. Somebody else is. Oh, same person. Okay, you're right this time. Okay, very good. Right. So the zinc chloride formula would be ZnCl2, and the formula for hydrogen is H2. Okay, so this equation now is the unbalanced equation. So now we have to balance it. So let me hear what you guys have to say about balancing this equation. Okay, let's see what this person says. Um, okay, so somebody is saying that we should put a 2 here. Not sure I agree with that because you already have one zinc here and you don't need to put a 2 there to balance that zinc. Somebody says, okay, so somebody is saying that it should be 1, 1. I'm sorry, 1, 2, 1, 1. Yes, I would agree with that. A 2 here, and that's it. And now the equation is balanced. All right? Okay, any questions about this one? Any questions? Okay, so let me just check this here. Scroll down here, see what's going on. Okay, so what I'm going to do is leave the rest of that for you to do. Um, because you should now be able to do the rest of this based on what we have done for the first 3 questions, all right? And that's pretty much all I have for today. Now, what I can do, in fact, what I will do is hang around until 10:45, which is when class officially ends. So if you want to hang around and do these and get my help, I have no problem with that. But pretty much that's all I have to say for today. What I'm going to do right now, actually, is set up a Dropbox for submission of this assignment. So let me do that right now. So today is okay, so this is assignment 6. So today is the 13th. Okay, so I am going to set the deadline for the 16th. All right, let me do some other things here. Okay, so available from now until the 16th. Okay, so please remember when submitting your assignments, make sure that it's in a PDF form, PDF document, as a PDF document. Make sure you do it in blue and black ink. Make sure you write your name on all the pages at the top. And what else? I'll remind you, I'll just post an announcement reminding you of all the conditions I require for submission of assignments. All right, so that's pretty much it for today. So feel free to leave, but like I said, I'll be hanging around here until 10:45, which is in the next 14 minutes. All right. Oh, by the way,
And he's like, I
oops,
can't do
sorry
that. I'm not good.
about that. By the way, I called the testing center. I think some of you have been having issues with signing up for slots or slots not being available for you to do the test. So I've extended the deadline. I told them that I will allow the deadline to be extended to, if I remember correctly, I said Wednesday. What date is Wednesday? The 18th. All right. So see if you can sign up for doing the test up to any time between now and the 18th. And if there are any issues with that, please let me know. All right. Okay. I think that's all I have to say by way of announcements. Oh, let me see. There are two. Okay, let me see what this person is saying. Yes, that's an answer to your question, Mr. Dennis Tannen. Um, oh, the 20th. Yeah, you probably need to reschedule. And this is an answer to Brissett. If you can't get it within before then, by the 18th. And let me see here. Somebody else is saying, oh, okay. You're welcome, Mr. Dennis R. Tannen. Okay, you're welcome, Mr. Brissett. Oh, okay, Miss Sweat. Let me check my email now, Miss Sweat. When did you send that email? All right, all right, whoops, whoops. Come on. Okay, let me do this. Okay. Um, You sent it February 11th? I'm not seeing an email here. Oh, wrong course. I'm sorry. Wrong course. Why is this thing? Okay, for some reason, oh, shoot. Hold on. Okay, okay, so I just my Wi-Fi here is slow for some reason, but I just saw your email. Um, let me see. Oh, okay. So I've already downloaded it and I've saved it. You're referring to assignment number 5, right? I thought I responded, but I guess I didn't. Um, right. So I haven't graded it yet. We'll get to it this weekend. So don't worry about it. I've already saved it, so it will be graded. All right. Okay. All right, folks. Four more minutes. So if you have any questions, feel free. Okay, let's see here. Okay, so if you sent, and this is to answer Bao's question, if you sent assignments 3 and 4, I've saved it. I probably haven't graded it yet. Um, I plan to do so this weekend. And you're asking about assignment number 5. So let me see. Okay, so what was the issue with assignment number 5? Okay, so if that's the case, you can email it to me. Um, oh, you emailed it already. Okay, so that's pretty much it. I'll retrieve it and save it. I plan to, grade, stuff that I've saved, assignments and so on, this weekend. So, you should see your grade. You should see that in your grade, definitely by Monday. All right. That's it for today. I'm